So our next learning objective, again, starts with a new number there, which means we're using a new term that isn't directly related to the previous sections. All right, so we're going to look at a new thing called the law of sines. All right, so we've used SOHCAHTOA a lot throughout all of our time with trigonometry. The problem is SOHCAHTOA only works with right triangles. There's a very specific type of triangle when you have just a right angle. And luckily, when we're building things and making things, we try to build things with right angles because they're kind of sturdy and work nice. But in general, there's not always going to be right triangles. And so is there any way we can keep using these trig ratios if we're talking about non-right triangles? All right, and the law of sines is going to be one of the ways we can do that. All right, so this is what the law of sines states. All right, that the ratio of the angle to the length of its opposite side is equal to all the other of those similar ratios. All right, so it's kind of complicated when you say it like that, but if I look at this diagram, if I compare my angle to the side across from it for all of these different parts of my triangle, if I take the ratio of the sine, so on the top, I can put it on the top or the bottom, so the sine of the angles goes on one part of the fraction, and then the side length goes on the other part of the fraction. So I could do it where the angles are on the top, or I could do it on the angles bottom. So these are kind of two separate things. It's not saying all 6 of these are equal. Either just the top 3 are equal, or the bottom 3 are equal. And also, I just realized I kind of made these look like minus signs. They're not minus signs. But again, just like all of our identities that we learned in our previous learning objectives, you don't have this memorized, but of course you need to know that it exists and kind of be able to access it easily. And again, it'll be on the exam, so you have that formula available to you. This is the law of sines. Just one thing that we're going to end up doing, if we're not going to have our nice kind of unit circle angles, we're going to need a calculator to figure out a lot of these problems. Let's see how we're going to use the law of sines. So this example, we want to complete the following triangle. So complete just means I want to find all the angles and all the sides. Well, the first one I can do, I have these two angles given to me. This angle here and this angle there. And I know the angles of a triangle add up to 180. So if I take 180 and I subtract these two angles, I know the leftover, which is 100, has to be this angle. So this angle here has to be 100 degrees. And now I can use the law of sines to figure out these missing sides I don't know. So how can I figure out B? Let's just go in alphabetical order. I want to find B first. Well, the law of sines says I use the angle opposite from the side. So B, I'm going to use the 100-degree angle. I'm going to use the other side that I do know, which is this 10. All right, that's an actual number, so that's going to help me. That's across from the 50-degree angle. And it's up to you whether you want to put the angles on the top or the sides on top. Let's just say we put the angles on top. So put the angle on top, I take the sine of 50. And I divide that by its corresponding side length, which is 10. And do the same thing. I'm going to take the sine of 100 and divide that by its corresponding side length, B. All right, so this is what the law of sines says, or law of sines says, is that this ratio or these ratios are equal. And now I need to solve for that B that I need to find. So what I can do is cross multiply. I'm going to get B times sine of 50 equals 10 times sine of 100. Keeping in mind that I want to get the B by itself, so now I'm going to divide both sides. I'm going to run out of room, so I'm not going to write, but I'm dividing both sides by sine of 50. I'm going to get B equals 10 times sine of 100 divided by sine of 50. All right, these are kind of two distinct functions, so you can't divide the 100 by 50. You have to leave them in the signs. All right, but now I'm just going to use my calculator. All right, 10 sine of 100. Divide that all by sine of 50. Again, double check. These angles that we're putting in are all in degrees, so make sure your calculator is set to degrees. Or if you're in Desmos, you have that little wrench to make sure it's in degrees. But this all tells me that B is 12.9. We'll just do one decimal point. That's enough. All right, 12.9 is my B value. All right, real quickly, we'll just do C. All right, C is across from the 30-degree angle. All right, so I can do the same thing. Let's just flip it around. All right, let's put the sides on top just so it doesn't matter. So I can show C over sine of 30 is equal to, we're putting the side on top, 10 over sine of 50. Cross multiply, c sine of 50 equals 10 sine of 30. And then divide so I can get c all by itself. And then again, just put this in the calculator, so I'll just type it in real quick. 10 sine of 30 divided by sine of 50. And I get 6.5. All right, so these are my answers to complete the triangle. Again, the first one we did as well up here. All right, so now we completed the triangle. We know all three angles and all three sides. One thing you can do to kind of check yourself as you're doing this, well, first of all, when you get to the practice, you can just make sure the answers are right. I have another thing you can do is the biggest sides are across from the biggest angles. So my biggest side is here, 12.9, and that's across from the biggest angle, 100. All right, next biggest one is 10. That's across from the next biggest angle, 50. The smallest side is 6.5, across from the smallest angle, 30. So that's just kind of one small way to make sure you didn't make some crazy mistake or you didn't have your calculator in radians or something like that. All right, so now go ahead and try this one on your own. Again, think about kind of the first thing you do is figure out this angle, then figure out A, and then figure out C. All right, so go ahead and do that and figure out these three values. And here are the answers I came up with. So A and 98 are together, C and 43 are together, and they both get paired up or compared to 22 and beta, which the very first thing I found was beta was 39. All right, so you're making these ratios. In this case, I kind of saved myself by just multiplying both sides by the fraction to get my variables by themselves. Type it in the calculator, and you get your answers. Again, double check, just make sure the biggest angles are across from the biggest sides, and that's the case in this one as well. All right, so just another example. All right, this one's a little bit different because now we have two sides and one angle. All right, we can do this in a similar way. All right, so let's label this side. All right, this would be C. And we got to figure out these two angles as well. All right, so let's figure out gamma first, which is actually a Greek letter we haven't used much, but it just kind of looks like a sideways fish if you draw it by hand. All right, but what does this say? Well, let's, again, just make sure we know which angles are related to which sides. All right, just go ahead going across the triangle. All right, well, we actually can't find gamma yet. I just realized because gamma has two things we don't know. It has the angle and the side. So really we have to start off by finding beta. All right, and if we find beta, I know the sine of the angle alpha is 35. We divide that by its side length, 6. And we know sine of this angle beta we don't know yet is divided by its side length, 8. So how can we figure out beta? This goes back to our very first learning objective in this unit, is that if I can get sine of beta equal to some number, then I can use inverse trig to help me. So the first thing I do is multiply both sides by 8. 8 sine of 35 over 6. You could simplify that fraction if you want. I'm just going to leave it because we're going to end up using a calculator anyways. We saw when we did our very first learning objective, if I want to figure out what this angle is, I can switch these two things by changing to sine inverse of this thing. And that's going to equal beta. So I can switch those two things in the parentheses and on the other side of the equal sign, right, as long as I switch the sign inverse or arc sine. Right, again, remember those two things are the same. And that's what I type in my calculator. So I'm going to type in arc sine 8 sine of 35 divided by 6. If you're doing this in a handheld calculator, really make sure you're careful with your parentheses to identify the fraction and what's in the parentheses and everything like that. I would end up getting beta is 49.9 degrees. And you may look at this picture and you say, well, you never know if my pictures are drawn to scale or anything like that, but you may look at a picture and beta 49.9 is an angle that's about that big. In the picture, the angle beta looks like it's an obtuse angle. It should be more than 90. And this is one thing you have to be kind of wary of with this law of sines, is this triangle is one triangle that fits these dimensions, but so is this one. with a 6 there. So if I kind of ignore this line and just look at this bigger triangle, that still has a side 8, a side 6, and an angle 35. And in this case, this small angle here is 49.9. And based on the way this triangle is drawn, these two sides are both 6. This blue angle there is the same. So even though it looks like the law of sine says my angle should be 49.9, the angle that I actually want is the one on the other side of that, which is when I take 180 and subtract that. And that's going to give you, whatever the calculator says, 130.1 degrees. All right, so there's one thing you have to be worried about when you're looking at your triangles. If it looks like an obtuse angle, sometimes the law of sines will give you, it'll always give you the smaller angle, but sometimes it's referencing this angle that you actually don't care about over here. So you end up taking 180 and subtracting that angle to get that. And now that I know beta, I can find my final thing, gamma. All right, gamma is 180 degrees minus 35 degrees minus 130.1. And gamma is going to give me, again, I have to just type this in the calculator real quick, 35 minus 130.1. That's going to be 14.9 degrees. All right, so as you start doing the practice for these problems, if you look at the triangle and the triangle looks like the angle you're trying to find is an obtuse angle, all right, sine inverse is always going to give you this small angle. So if you're actually trying to find the bigger angle, you just subtract it from 180. And that'll give you this bigger angle here rather than the smaller blue angle that the law of sines is actually giving you. So even though this law of sine exists, it doesn't always give you the exact right answer. Sometimes you have to do a little bit of thinking about what that angle should actually be. All right, so go ahead and try this problem. All right, we have something similar. We have one angle and two sides. All right, go ahead and use the law of sines to find those missing angles. And here's the solution I came up with. So beta ends up being 48.3 degrees, and alpha is 46.7 degrees. All right, one way you can tell these are the small angles is if you look at the picture, they're the small angles. But again, there's no guarantee that they're always drawn to scale. Sometimes they could do that to kind of confuse you. All right, but let's say you tried to do the thing that we did last time. So if you get this angle first, you can find the kind of opposite angle by taking 180 and subtracting that answer. And the kind of obtuse version of this angle would be 131.7. So that was kind of that explanation I gave on the last slide. But if you were to do that and try to find the last angle, so now I know one is 85, I just found that one, it would give me a negative 36.7 for that missing angle. And of course, it doesn't make sense to get a negative angle in this right triangle. So it says that this isn't possible, so it had to be this smaller angle here, which also guarantees this smaller angle there. All right, so sometimes you can try to find these kind of bigger angles like we had to do in the last problem, but sometimes it just doesn't work out, and that kind of guarantees that smaller angle is the answer. All right, so keep that in mind when you're going through practice problems. Also in the practice problems, they actually are drawn to scale, so if it looks like a small angle, the answer is small. If it looks like an obtuse angle, then it'll be one of those bigger angles. All right, so to finish up for your multiple choice question, all right, what is the value of x in this picture? All right, so you don't need to find everything, just that value of x.